Imagine stepping into a teleportation device, pressing a button, and instantly appearing on the other side of the galaxy. Science fiction has sold us this dream for decades, promising instantaneous travel without the inconvenience of actually moving through space. But Stephen Hawking's analysis of teleportation reveals a horrifying truth that most people never consider. Every time you teleport, you die. The person who emerges at the destination isn't you. It's a copy with your memories, convinced it's the original. This isn't philosophical speculation or science fiction horror. This is cold, hard physics. Hawking's investigation into the fundamental nature of information, consciousness, and identity reveals that teleportation, as commonly imagined, represents the ultimate violation of what makes you, you. The physics of copying and reconstructing matter at the quantum level proves that teleportation is actually a sophisticated form of murder, followed by the creation of a duplicate. The implications are more disturbing than most people realize. If teleportation technology were developed tomorrow, millions of people might unknowingly commit suicide while believing they're simply traveling. The copies would have no idea they're not the originals. They would possess all the same memories, personalities, and beliefs about their continuous existence. What if I told you that Stephen Hawking's analysis proves that consciousness cannot be copied or transferred, only destroyed and recreated? That the quantum mechanical processes required for teleportation would necessarily eliminate the original consciousness while creating a new one that merely thinks it's continuous with the first? This is the story of why teleportation represents the most insidious form of death imaginable. One where the victim doesn't even realize they've died, and where perfect copies walk away convinced they've simply taken a very fast trip. Before we explore Stephen Hawking's terrifying analysis of why teleportation kills you and creates copies that think they're you, hit that subscribe button because we're about to uncover the physics that proves science fiction's most beloved technology is actually a nightmare. Stephen Hawking's investigation into teleportation began with a fundamental question about the nature of identity and consciousness. What exactly makes you you? Is it your physical body, your memories, your patterns of thought, or something more fundamental that cannot be copied or transferred? The physicist's analysis revealed that this question isn't just philosophical. It has concrete physical implications that determine whether teleportation is possible without destroying the original person. The most common conception of teleportation involves scanning every atom in your body, recording their exact positions and quantum states, transmitting this information to a destination, and then reconstructing you perfectly from available matter. This process seems straightforward until you consider what Hawking called the continuity problem, the fact that the scanning process necessarily destroys the original while creating what appears to be an identical copy. Hawking's analysis revealed that the quantum mechanical principles underlying matter and consciousness make true teleportation impossible without killing the original. The physicist demonstrated that consciousness isn't just information that can be copied, it's a continuous process that emerges from the specific physical interactions occurring in your brain at every moment. The quantum no-cloning theorem, which Hawking helped develop, proves that it's impossible to create perfect copies of arbitrary quantum states. This means that the exact quantum configuration of your brain, which may be crucial for consciousness, cannot be duplicated without destroying the original. Any attempt to scan and copy your brain's quantum state would necessarily alter or destroy the original state in the process. Think about what this means for teleportation. The scanning process required to capture your complete physical and quantum information would need to interact with every atom in your body, measuring their positions, velocities, and quantum states with perfect precision. But the act of measurement itself changes quantum systems. You cannot observe a quantum state without disturbing it. Hawking calculated that the level of scanning required for perfect reconstruction would necessarily disrupt the delicate quantum processes occurring in your brain. The measurement process would destroy the very consciousness it's trying to preserve, leaving behind only the information needed to create a copy that thinks it's you. The physicist also explored the thermodynamic implications of teleportation, revealing additional reasons why the process would kill the original. Perfect scanning would require extracting enormous amounts of information from your body, approximately 1045 bits of data, to specify the position and state of every atom. The energy required for this information extraction would necessarily heat your body to temperatures that would instantly destroy all biological processes. Even if we could somehow extract this information without thermal destruction, the reconstruction process presents equally insurmountable problems. Assembling 1028 atoms into the precise configuration of a human body would require manipulating matter at the quantum level with impossible precision while avoiding the random thermal motions that constantly disrupt atomic positions. Let me ask you something that might fundamentally change how you think about identity and consciousness. If a perfect copy of you was created with all your memories and personality traits, but you remained alive to meet this copy, which one would be the real you? Share your thoughts in the comments below, because this question reveals the core problem with teleportation technology. Hawking's analysis of consciousness revealed why teleportation represents a fundamental category error, treating consciousness as information that can be copied rather than as a continuous physical process. The physicist argued that consciousness emerges from the specific pattern of neural activity occurring in your brain at each moment, and this pattern cannot be paused, copied, or transferred without being destroyed. Consider what happens during the teleportation process from the perspective of consciousness. The scanning begins, and your brain's neural activity continues normally as the process measures and records your physical state. But at some point during scanning, the measurement process begins to disrupt the delicate quantum states that may be crucial for consciousness. Your subjective experience, your stream of consciousness, is interrupted and ultimately terminated. Meanwhile, at the destination, matter is assembled into a configuration identical to your original body. This new brain begins functioning exactly as yours did, with all the same neural patterns and memories. From the perspective of this new consciousness, it seems as though it's simply teleported. There's no subjective experience of death and recreation, only the sensation of instantaneous travel. But Hawking's physics proves that this is an illusion. The original consciousness was destroyed during scanning, and a new consciousness was created at the destination. The copy has no way of knowing it's not the original, because it possesses all the same memories and thought patterns, including the memory of deciding to teleport. The physicist also explored what he called the branch point problem, the moment during teleportation when the original still exists, but the copy is being created. If both versions exist simultaneously, even briefly, which one has the stronger claim to being the real person? Both would have identical memories and personalities. Both would believe themselves to be the original. This scenario reveals the fundamental flaw in thinking about teleportation as transportation rather than as copying. You're not being moved from one location to another. You're being destroyed in one location while a copy is created in another. The copy may be perfect in every measurable way, but it's still a copy, not a continuation of the original consciousness. Hawking's investigation into quantum consciousness revealed additional problems with teleportation. If consciousness depends on quantum processes in the brain, as some theories suggest, then the quantum no-cloning theorem makes it impossible to transfer consciousness without destroying it. Quantum states cannot be copied perfectly, only moved from one system to another, and moving them requires destroying the original state. Recent research in quantum biology has revealed that the brain may indeed rely on quantum processes for consciousness and cognition. Quantum coherence has been observed in neural microtubules, and some researchers believe that consciousness emerges from quantum information processing in these structures. If this is true, then teleportation would necessarily destroy the quantum basis of consciousness while creating a classical copy that lacks the original's quantum properties. The physicist also analyzed the information-theoretic aspects of consciousness, revealing why perfect copying is impossible even in principle. Consciousness isn't just a static pattern of information. It's a dynamic process that continuously generates new information through its interaction with the environment. This ongoing information generation cannot be captured by any finite scanning process. Moreover, the act of scanning consciousness would necessarily alter it. The measurement process would introduce new information into the conscious system, changing its state in unpredictable ways. You cannot measure consciousness without changing it, which means you cannot copy it without destroying the original. Hawking explored various proposed solutions to the teleportation problem, including gradual replacement scenarios where parts of the body are teleported sequentially rather than all at once. But his analysis revealed that these approaches still face the fundamental problem of consciousness continuity. At what point does the original consciousness end and the copy begin? The gradual replacement scenario sometimes called the ship of Theseus problem, asks whether you remain the same person if your body is replaced piece by piece. Hawking's physics suggests that consciousness depends on the continuous operation of neural processes, and any interruption of these processes, even briefly, would terminate the original consciousness and create a new one. The physicist also investigated quantum teleportation, the real-world phenomenon where quantum states can be transferred from one particle to another. But quantum teleportation actually supports his argument against consciousness teleportation. The process necessarily destroys the original quantum state while creating an identical state in a different location. The original particle doesn't travel. Its quantum information is transferred while the particle itself is destroyed. If consciousness depends on quantum processes, then consciousness teleportation would work the same way. The original consciousness would be destroyed while its information is used to create a new consciousness elsewhere. From the outside, it would appear that the person had teleported, but from the inside, the original person would have died. Hawking also considered the ethical implications of teleportation technology. If teleportation kills the original while creating a copy, then using such technology would be equivalent to suicide, followed by the creation of a new person with your memories. Society would need to grapple with questions about identity, legal continuity, and the rights of copies. Would a teleported copy have the same legal rights as the original? Would they inherit the original's property and relationships? Would marriage vows still apply if one spouse teleports and becomes a copy? These questions reveal the profound social disruption that teleportation technology would cause if it were ever developed. The physicist's analysis also revealed why teleportation accidents would be particularly horrifying. If the scanning process failed partway through, you might be left partially destroyed but still conscious, aware that you're dying while a copy is being created elsewhere. If the reconstruction process failed, you would die while no copy is created, making teleportation a form of suicide with no guarantee of resurrection. Even worse, technical glitches could result in multiple copies being created, each convinced they're the original. Imagine waking up to discover that several identical versions of yourself exist, all with equal claims to your identity and life. Which one would be the real you? How would society handle the existence of multiple identical people? Hawking also explored the possibility that consciousness might be more robust than his analysis suggests, that it might survive the teleportation process through mechanisms we don't yet understand. But his investigation of known physics suggests that consciousness is far more fragile and dependent on specific physical processes than most people realize. The physicist's work on black hole information paradoxes provided additional insights into why consciousness cannot be copied. If information cannot be destroyed, as quantum mechanics suggests, then consciousness might be a form of information that cannot be duplicated without violating fundamental physical principles. Recent advances in neuroscience have only reinforced Hawking's conclusions about teleportation. The brain appears to be far more complex and delicate than early researchers realized, with consciousness emerging from incredibly precise patterns of neural activity that depend on exact timing, quantum coherence, and continuous metabolic processes. The discovery of neural quantum effects, microtubule quantum processing, and the role of electromagnetic fields in consciousness all suggest that the brain operates according to principles that make copying impossible without destruction. Consciousness isn't just software running on biological hardware, it's an emergent property of specific physical processes that cannot be separated from their substrate. Hawking's final analysis of teleportation painted a picture of a technology that would be simultaneously miraculous and horrifying. Perfect copies of people could be created with all their memories and personalities intact, but the originals would necessarily die in the process. From the outside, it would appear that people were traveling instantly across vast distances, but from the inside, each use would represent death and replacement. The physicist understood that this conclusion would be deeply disturbing to anyone who dreams of teleportation technology. The idea that we could travel instantly to distant stars is one of science fiction's most appealing promises. But Hawking's physics reveals that this promise comes with a terrible price, the death of everyone who uses it. Perhaps most disturbing is the realization that the copies would never know they're copies. They would wake up at their destination convinced they had simply taken a very fast trip, unaware that the original person had died during the process. They would live their lives believing in their own continuity, never realizing they're essentially sophisticated zombies with borrowed memories. Hawking's work suggests that true teleportation, the kind that preserves consciousness and identity, may be impossible according to the fundamental laws of physics. The quantum mechanical principles that govern matter and information make it impossible to copy consciousness without destroying it, and the thermodynamic requirements of perfect scanning would kill any biological system. This doesn't mean that rapid transportation is impossible. Technologies like wormholes or faster-than-light travel might allow genuine movement through space without the copying problem. But teleportation as commonly imagined, scanning, transmitting, and reconstructing, represents a fundamental misunderstanding of what consciousness is and how it relates to physical matter. The next time you see teleportation in science fiction, remember Stephen Hawking's terrifying analysis. That character stepping into the teleporter isn't taking a trip. They're committing suicide while creating a copy that thinks it's them. The technology that seems like the ultimate convenience is actually the ultimate horror, death disguised as transportation. If this exploration of Stephen Hawking's analysis of teleportation has changed your perspective on one of science fiction's most beloved technologies, make sure to smash that like button to support more investigations into the physics behind fictional technologies. Subscribe to our channel and hit that notification bell so you never miss our deep dives into the science that reveals why our favorite sci-fi concepts might be impossible or horrifying. Share this video with anyone who's ever dreamed of teleportation, because they need to understand the terrible price such technology would exact. And let me know in the comments. If teleportation technology were developed tomorrow, would you use it knowing that it would kill you and create a copy? How would society handle the existence of perfect copies with identical memories and personalities? What other science fiction technologies might have hidden horrors that we haven't considered? Drop your thoughts below and join our community as we explore the physics that reveals the dark side of our technological dreams. The universe operates according to laws that don't always align with our wishes, and sometimes the most appealing technologies come with the most terrible costs.